Hi and welcome, ladies and gentlemen. Today we are talking about in-order traversal of binary trees. As usual, you find the source code link down in the description below. That is my Git repository where you find the source code of all my videos. Well, if you want to traverse a binary tree in order, you want to traverse always the left subtrees. Then when you're at the leaf, you print it. And then you print the root, then you go to the right subtree. Well, and with this scheme you keep going until you finished all the nodes. Let's have a look at an example. Well, here you want to start with the first tree, that is the root node, and there you go to the left subtree, that is 2, 4 and 5. So when you're there, you have again a left subtree, and that is in this case 4. Well, and then we are at the 4 here, so now we want to print the 4 because it is a leaf. So, since we are now at a leaf, we can go back to our root node, and in our in-order traversal we print the root node now. So then we go to our right subtree, and from there we see, okay, we are again at a leaf node. So we can print our leaf node there. Then we are done with the left subtree of 1. So we are done with, we can print the 1 now. So that is the next point in our traversal. So we can go to the right subtree of the 1. There we have 3, 6 and 7. So we go to the 3, and the 3 has a left subtree. That is the 6, so we go to the 6. The 6 is a leaf node, so we can print our 6. Then we go back to the root node of this subtree, and that is 3. So we go in there, and we can print our 3. And then we just have to go through the right subtree again, and then we can print that, and we are done with our in-order traversal. Always the left subtree first, then the root node of the subtree, and then our right subtree. Well, if you want to have a look at it as an algorithm, here we have the node algorithm, where we have a result, and we say if it is a leaf node, then we return our leaf node as a single list, and then we go in and say we traverse our right subtree, and we append the results of we want to go to our left subtree, and we want to append the result of our left subtree to our result list. Then we do the root node, and then we go through our right subtree. And when we are done with everything, we want to return our result. Let's implement that in Python. Well, for that I use a program that I worked earlier with, and that is our binary tree as a list. Well, if you don't know where what that is right now, then have a look at the video. I print the link up at your screen. So we go in now and say inorder _ traversal as a new file .python, and there I simply copy now our binary tree as list function, which consists basically of a node who has a left and right subtree, and it stores a value. That is the most important point there. You can have a look at the video. Everything is is explained in detail. Well, now I want to add here a new method, and I call that inorder traversal. And that gets just our self, because we always want to start our in-order traversal at the root node. And here I say initiates the in-order traversal. And we say returns a list of nodes in Inorder Traversal. Alright, and there I for now just go in and say pass, because the main or the main thing that happens here is done recursively, and for that I need a little helper function. And I will write that as a private function. That's why there are these two underscores, and I call that Inorder REC for Inorder Traversal Recursive, or however you want to name it. Well, let's call it here Inorder Traversal Recursive. And that gets self again, and it gets the current node it is working on. And that is just a helper method. There we need our result, and we will initiate that or instantiate that as an empty list. Then we want to have a look if the node is a leaf node. So here we say if node.left equals to none and node.right equals to none, then we return a singleton list with our current node. Else, we don't really need an else here. So we go in here and say otherwise we want to go through the left subtree, or we want to go through the right subtree. Now here we say we want to call self.inorder traversal rec, so on the left subtree, and there we say node.left, and we do that only if our left subtree is not none, if node.left is not equal to none. If so, then and what we get back is a list of nodes of the subtree. So it's basically the Inorder traversal of the subtree. And there we can say now, since it is a list, we extend our result with these nodes. Alright, so then we said once we've done the left subtree, we want to keep going with the node itself. So we can say result.append node here. And once we are done with that, we can go in and check if the right subtree is not empty. And then we go through our right subtree, result.extend, and we call our recursive version here again on our node.write. And once we are done with everything, then we can return our result. What we have to do now here when we invoke our Inorder traversal is we have to call our recursive version, and that is self.inorder traversal rec, and we want to invoke that with the argument of the root node. So here we say self.root, and that should be it already for our Inorder traversal. Let's try it out. So I have here the tree 1, 2, 3, 4, 5, 6, 7 as we had it earlier. And now I want to say here print, and there I call bintree.inorder traversal. And that should give us a list of nodes. Let's see if that works. And it does work here, very fine. But what I really want to do is I say for node or for value in, and there I want our Inorder traversal now. Here I want to print the value, print value. And that we not be confused with our breadth first search that we print here earlier, I simply make here a print, and that should be fine now. So we have an empty column, an empty row there. Let's print it again. And here these are nodes. And we want to print here node.value. And so we see, as earlier, we are at the 4, then we print the root node of the subtree, then the 5, then we print the root node of the wall tree, it is a 1, so we are now in the right subtree of the wall tree. Then we go to the 3, 3 has a left subtree, so we print the 6, then we go back to the 3, which is a root node, and then we go to the 7 and we are done. Well, ladies and gentlemen, if you liked that video, give it a thumbs up and subscribe to the channel when you want to get informed whenever I'm uploading new videos. I really appreciate your comments down in the comment section, and thank you very much for watching, and we see each other the next time. Have a great day. Bye.